watch it later.
Okay, thanks.
Okay, so you go to the halfway mark, which is pi.
Hmm.
Then you take half of that, which is pi over 2. And then you go 1/2, 2/2, then there's 3/2, and then 4/2. So do you remember these were your 5 critical points that you used to graph?
Hmm. Well, and also, like you did one half, two half, three, like simplifying. Could you do that for everything? Like
Oh,
if
and
it was
this shouldn't have been a fourth. That should have been a half. I'm sorry. I said a
okay.
half two out loud and I didn't write. But yes, you can. And I'll show you an example because one of the examples, the period is a little different.
Okay,
So yes, that'll be a good one to look at.
sounds good.
Now, this one has no vertical shift or phase shift. The only thing that's changing is the amplitude. So normally your amplitude would be at 1, but since the amplitude's at 2, then you have to go all the way down to -2.
Okay.
Now for the sine function, your critical points, Nick, I need to just put you on hold for a second. Uncle Sam is,
All right, that's fine.
I'm going to pause the recording. Okay, resume recording. Here we go. All right, so the 5 critical points. Now, this is the really important part. It makes it much easier for graphing. For
Okay.
a sine function, it's the intercept, then the maximum, then an intercept, then the minimum, and then an intercept to graph one period.
Okay, I
So
remember that. Yeah.
for this function, we're going to start at the intercept. We're going to go up to the maximum. Then we're going to go to the intercept, down to the minimum, and then back to the intercept. And so
Okay.
that allows us to draw the whole graph. Now, the only thing you want to be careful of is if they tell you to graph multiple periods, then you'd have to repeat it.
Yeah.
Okay.
Okay. I got you.
All right. So any questions about this one? Does that kind of refresh your memory a little bit?
Yeah, I remember talking about the intercept max like that stuff last year, so that was helpful.
Okay.
It's
All
like
right.
the opposite for cosine, right?
Right. Well,
It
yes,
goes asymptote first. You
there's
said?
no asymptotes on these. But it
Okay.
starts at the maximum first, which is what perhaps you're
Uh,
thinking. That might be what you're thinking about. All right, so here's another one of the questions, and I thought this will be a good one to look at because it has what you were referring to before, like it has a different period.
okay.
Okay?
Wait, can you scroll up for a second again?
Oh, sure. Hang on
Yeah,
one second.
that's one thing.
I'm sorry. At
Okay,
what
that's
at what
that's good. I got it.
I'm going to send you these notes too.
Okay, thank you. All right, I got it.
Okay. All right. So on this next one, this is cosine. And one of the things that you'll notice also about this particular problem is that this value here, right here, this is that k value, but it's on the other end. So some people like to rewrite it
Hmm.
so that it's in the correct form. So it makes it a little easier to identify all the values. Does that make sense?
Yeah.
So if I wrote my value underneath, this would be a cosine b of x, there's no h, plus k.
Okay.
All right. So my amplitude is going to be that a value again. And that means my amplitude is going to be 1/4. Now, notice that I didn't use the negative. Do you remember what the negative stands for?
Um, no. Well, I know you didn't use the negative because we're going absolute value, but
Right. What the negative tells you is that you reflect it across the x-axis.
Okay.
Okay, and we'll talk about when you graph that, what that looks like. All right?
Mhm.
Then your period, remember, is going to be b or 2 pi divided by b. So in this case, that's 2 pi divided by 3 halves. So what does that give you as a period?
Halves. I'm not sure.
Go ahead and do you have your calculator, hon? Hopefully you have that TI-30 now.
Yeah, I will grab it.
I just want you to practice doing it with the calculator, especially when you have those fractions there too, because that's going to be important. You don't want to get into a quiz or test situation and not have practiced that. Does that make sense?
Yeah.
Okay.
I got it.
All right, honey.
It's 4 pi over 3. Is that correct? Hey, Lisa. Can you hear me? Hello. Can you hear me? Oh, I can't hear you for some reason. I don't know. Exit meeting and re-enter. Okay. Rejoin. Let's do that.
Okay, so I'm going to resume recording.
Nice.
All right. So where were we? Okay, so then vertical shift. Remember, your vertical shift is how far left or right. That's determined by the K value. So
Yeah.
in this case, your vertical shift, or I'm sorry, vertical shift is up and down, so that's going to be 3.
Okay.
And
Yeah, plus 3. Yeah,
that's
I
the
gotcha.
K value right there. Now for the phase shift, that's your left and right. That's none. There is no phase shift.
Okay.
And
That's that.
that's because there's no H value.
Okay.
Okay? So the only other thing I want to mention before we start graphing it is remember your 5 critical points?
For cosine, it's maximum intercept,
Mm-hmm.
minimum intercept, max, something like that. It's like the opposite.
Correct. But because we have a reflection over the x-axis,
Yeah.
instead of starting at the maximum, we're going to start at the
Minimum. Okay.
minimum. Are we good?
Yeah, 1 second.
Tell me when you're ready. Can you still hear me?
Yeah, we're good now.
Oh, okay. Made me nervous for a minute.
Yeah, that was stuff. All right, I'm ready for the graph.
You ready for the graph? Yes?
Yeah.
Okay, so the longest distance is 4 pi over 3. Now I got that from the fact that that's my period.
Yep.
Okay, so I make the halfway mark. The halfway mark is 4 pi over 6, and we'll talk about reducing this later, but let's leave it as 4 pi over 6, okay?
Okay. Yeah.
And then half of that is 2 pi over 6.
Right.
Okay. Now you could look at this as we'll change it in a minute. But see how this is 2, 6?
Yeah.
You got to go up by the same increments. So 2, 6, 4, 6, and then 6, 6.
Okay.
And then this is really 8 over 6.
Yeah.
Okay? So now, so do you see how I got all those?
Yeah, but would 6 pi over 6 not reduce, or?
Yes, everything reduces. So once I've got it set up, if you want, you can reduce it. So for example, let me grab the eraser, not that, whatever that is that's in. Okay, grab the eraser. So I'm going to erase this and I'm going to change it to 2 pi over 6 is really pi over 3.
Yeah.
You know what? It just doesn't like that pen there. Come on, pen. Pi over 3. And then this really reduces to 2 pi over 3. And then this really reduces to pi.
Okay. And then the other one stays the same.
Right, and that's already reduced.
Yeah.
Now the next thing that you want to take into consideration is your vertical shift. So instead of using the x-axis, you're going to shift up 3 units. So you're going to, that's where your midline's going to be. Do you remember drawing a new midline?
Yeah.
All right. And then from the midline, we're going to go, if this is 4 and this is 2, we're only going up a quarter because that's your amplitude.
Okay. Yeah, yeah. 1/4. Yeah.
Is it, are you, that makes sense?
Mm-hmm.
Okay. So now you're ready to actually start graphing. Keeping in mind that you're reflecting. So instead of starting at the maximum, you're starting at the
Minimum.
minimum, which is 1/4 below the midline.
Okay.
Then you're going to the intercept. Then you're going to the maximum, and that maximum's only that 1/4 above the midline.
Hmm.
Then back to the intercept, and then down to the minimum, and then you would keep going.
Okay. Okay.
What do you think?
I just like messed up at one point, so I had to redraw my dots, but I got it.
Okay.
There we go. All right, I got it.
All right, I'm saving this for you before I lose it. Everything else going well, sweetheart?
Yeah, this is the only like tough class probably for me now.
Okay. I was
Yeah.
hoping that maybe we'd be able to look at your syllabus so I can help you figure out really where your grade is right now. You
Okay.
know, looking at
Yeah.
percentages and stuff like that.
Yeah. I'm not sure how good it's gonna be.
Don't worry about it. It's not a big
Yeah.
deal. Trust me. You're not the first Bizzuto to struggle his freshman way through. So,
Yeah.
okay, so let's look at this one. So I'm going to give you a second to figure out what all the critical information is.
Okay.
Amplitude, period, vertical shift, and your phase shift. So you go ahead and figure out what all those are
Okay.
first.
So amplitude's 1, right?
Perfect. And then what does that negative tell us that's in front of it?
That would be a reflection.
Right.
Uh, period. Uh, Is the series is 2 pi or
It is. That's correct. Because your b value here is 1.
yeah.
So 2 pi over 1 is simply 2 pi.
Okay. Vertical shift. Is the vertical shift to 3 pi over 4? Or because that's not like the end of the problem.
Right. So this is really like saying plus 0.
Okay, so no vertical shift.
Right. There's none.
All right. The phase shift is h, right?
Correct. It's h over b. So what is the value of h?
Is it 3 pi?
3 pi over 4. And then b is just 1 because that's what's in front of the x.
Yeah, so it's just 3 pi over 4.
So it's just 3 pi over 4. Now, here's the question. It's positive 3 pi over 4. So are you shifting to the right or the left?
To the left.
To the right.
No, really? It's not the opposite one?
It is opposite because see how it says negative 3 pi over 4 minus 3 pi over 4? That's where the opposite comes in.
Alright. So we're set up the graph now.
Now we're ready to set up the graph. So this one's going to be a little bit different, so bear with me for a second, okay?
Alright.
So we are going to start off with that 2 pi, mark off the halfway point, which is pi over 2, and mark off half of that, which is pi over 4. Or wait, I don't know where pi over 2 came from. Sorry, half of that is pi. Let me grab that eraser.
Okay.
Give me a second. That's pi. And this is pi over 2.
Okay.
So that's 1/2, 2/2, and then 3/2, right?
Yep, 3 pi over 2.
Your amplitude is 1, so it's still going from 1 to -1. Now, whenever you have a phase shift, I don't know if you remember me talking about this or not, but you draw what's called the ghost. And that's everything before the phase shifts. So I have my amplitude, my midline, my period, my vertical shift. Everything's included. Now, this is negative sign. So where would I start?
The intercept.
Right. So it's the intercept.
And then is it the minimum?
Then the minimum. So that's what that looks like, the minimum. And then notice that I'm drawing with a light dotted line.
Yeah.
And that's because that's not my final graph. That's the ghost graph.
Okay.
Because what I have to do now is I have to take into an account this phase shift.
Yep.
So halfway between 0 and 1/2 is a fourth. So this is like 1/4, 2/4, 3/4, 4/4,
Okay.
5/4, 6/4, 7/4, 8/4, and 9/4. Does that make sense?
Yeah.
And then I'm going to go ahead and extend this a little. This will be 10/4, and this would be 11/4, and you'll understand why I'm extending it a little in a second. But we have to take this original point here, which was the intercept, and we have to move it all the way over to here, which is my 3 pi over 4, which is my phase shift.
Okay, wait, but why is it 7 pi over 8 and not 4?
It should be 4. Because
Okay.
I didn't even say 8 out loud, did I? And I wrote 8. I have no idea what I was. Sorry about that. They're all 4s.
9 pi over 4. Okay.
Okay? So here's the key here. I'm going to pick this graph up, and I'm going to move each point over 3/4. So this point here, the intercept at 0, 0, is going to move here to 3 pi over 4.
Okay.
This one's going to move over 3. 1, 2, 3. So now the new minimum's right here.
Right past pi. Okay, yeah.
Now I'm going to take this intercept. 1, 2, 3. See what's happening?
Yeah.
Okay. And then I'm going to take this maximum, and it's going to move over 1, 2, 3. So that now it's over here.
Okay.
Okay. There's my new intercept. Here's my new minimum. And there's your graph.
Okay.
So I took each point and I moved it over 3/4.
Yep, there we go. I got it. Yep, mine looks bad.
The phase shifts are probably the most difficult.
Okay, like the hardest kind of graph you could get.
Right, is when you got that phase shift.
Alrighty.
So, but do you see how I drew the ghost first?
Yeah, you have everything ready to go.
Exactly, exactly.
Alright.
All right, so then let me just save this because I'm going to open this graphing calculator that's online.
Okay.
Called Desmos. Do you use that at all, or?
No, I don't.
Okay. Desmos is just a graphing calculator. And the last question that was on that worksheet had to do with the fact that they actually gave you an equation. And so the equation they gave you was 60 minus the cosine, 30 cosine of, and then it had x, and then let me put in pi. Yeah, pi.
Okay.
Divided by 6. So that's the equation that you were given.
Yeah.
Now, by the way, just looking at this equation, notice that your amplitude is what?
2 pi over 60.
Your amplitude, sweetie. Remember, your amplitude's going to be that A value. So your amplitude is
30.
30. You have a vertical shift of 60.
Okay, yeah.
Okay, just in case you were asked those questions. I'm not saying that's what you're going to be asked, but
that 60 could be at the end too.
it should be at the end. But it's just another way to write it.
Alright.
Okay? Alright, so let's go ahead and look at this graph. I don't need the keyboard, but I do need the graph. And it's probably not showing me the graph because I need to change my settings. So I've got, for example, my x, I want that to start at 0. Yeah. I'm not going to have any negative values. Now your period, what's your period? Your b value, let me just bring up that piece of paper and we'll figure these values out first.
Okay.
Oops. Okay. All right. It's going to keep moving this because let me get it back. Wait, give me 1 second here. It's moving the graph around. I'm just going to open a new sheet of paper.
All right.
Give me one. File. Open. No. All right, so the equation itself is 60 minus 30 cosine of pi over 6x.
Yep.
So we know the amplitude is 30, right?
Mm-hmm.
We know you have a vertical shift of 60. What's your period?
2 pi over 30.
Nope. Here's your b value right here. So it's going to be 2 pi over 6.
Okay, yeah, I see that. 6. Okay.
So it's the period.
Yeah, I got it. I was writing it all down.
Oh, okay, honey.
12.
12. Now that makes sense because remember this word problem is about the 12 months of the year.
Yeah.
Okay. Now, they are telling us in the problem that x equals 0 represents January. So it's not like 1 represents January. 0 represents January, x equals 1 represents February, etc.
Yeah.
Okay, but now that we have all these values, what it does is it shows us how we're going to set up our axes. So our period's going to go out to 12, right?
Mm-hmm. Yeah, up and graph.
The vertical shift means that my midline is all the way up here at 60.
Oh, wow.
Does that make sense?
Yeah.
And since my amplitude is 30, that means that it's going to be as high as 90 and it's going to be as low as 30. Now we want to keep that in mind when we're going to draw our graph. Also, what that means in the context of the problem is that the temperature ranges between 30 degrees and 90 degrees, and it goes back and forth
All right.
over the year. All right, so keep this in mind when we look at the graph. So for our x values, even though we want to start at 0, we probably want to go to something like 13. We want to get past the 12, correct?
Past the 12 months, you're saying?
Right, because remember that when we look at the drawing, we want to go at least to 12 to see the whole period.
Oh, yeah.
Normally, when you're looking at a graph, you want to look at something, we could even start at -1 so that you're not directly on top of it. Does that make sense? You can see the whole graph?
Yeah.
All right, the next thing is that your y value, what do you think your lowest y value should be?
30?
We could do 30. We might want to do 25 simply because we want to be able to see below it.
Oh, yeah, that's true. Okay.
Does that make sense?
Yeah.
And then what would your highest value be?
95?
95. And if you want, you can go up by increments of 5.
Okay.
You know, it might make it a little easier to see the graph. All right, and then as far as your step on the first one, you probably want to go as 1.
Okay.
And what I really like about the Desmo graph, for example, I could add a label here saying that my x-axis is the months of the year,
Mm-hmm.
and my y-axis is the temperature. Although I probably spelled that wrong. But anyways. All right. So how do I get it to graph?
Yeah.
There we go.
All right.
What do you think?
So that would be what my graph would look like if I drew it on the paper, kind of?
If you drew it on the paper, that's what it would look like. Notice that right here where you see 60, Nick, that's where that midline is. Kind of see how it's the same distance above and below that midline.
Yeah.
What's also nice about this is notice that I can click and drag my graph to see everything.
Like more, yeah.
If I wanted to know it, like for example, if I wanted to know 2 years out what it looked like
Mhm.
once you set it up. But do you understand how we set
Okay.
the window up based on what we knew about the graph?
Yeah, I just did a little extra so you could see it all and stuff.
Right, right. You always want to do that. All right, so here are the questions. Ready?
Mhm.
It asks, find the maximum afternoon temperature to the nearest degree for each of the following months. Now, I believe you can look at this in terms of a table. I'm trying to remember where that was. That you can see the table in Desmo. Oh,
How would I do that without
right here.
using this
Add the
though?
table. Pardon me?
How would I do all this without the Desmos though?
Well, you would do it on your graphing calculator. Don't you have a graphing calculator?
I'd have to check. I've just been using my TI-30, so
Okay, you should have your graphing calculator. I know you did have one at one time.
yeah. I'll have
Okay,
to
done.
that.
Convert to a table. There you go. Here's my table.
Okay.
Okay, and I just hit convert to table. So in January, which remember is 0,
Mhm.
so in January it's 30 degrees.
Yeah.
Okay, the next one is February. So what would the month number be for February?
1.
Or you're right, February, but February's 1, so it's 34 degrees is the
Yeah.
temperature, correct? The next
Yeah.
question asks about April. So what is the month number that you would use for April?
5.
No, remember it's one less.
Oh.
So remember January was 0, February was 1,
Yeah. April 3. Okay.
so April would be 3.
Yep.
And notice that when you put the 3 in, it tells you it's 60 degrees.
Okay.
So
I'm gonna
then
put the dot on there.
what's August?
7.
And there's your value.
Nice.
And then October,
9.
there you go.
60. Okay. So on my graphing calculator, I can type it in kind of the same like that, or I just like look through the table.
You just look through the table for those values. They'll automatically be in there.
Okay. Good. Well,
All right, so that was the worksheet that you had sent me.
yeah.
The other worksheet, I just could not read anything.
That's okay. I have some other problems, like if you want to go over some right now.
Sure. Let me see if I can change the presenting. In a million. Here we go. Let me go here. That's what I need to do. Let's go here. All right. So let me just pause the recording. This is going to be the choppiest recording ever, but just in case you need something.
Okay.
All right, so the rules are if you take the sine of negative x, that's equal to negative sine of x. These two things mean the same thing. That's what he's referring to when he says cofunction.
Okay.
If you take the cosine of negative x, all right, the cosine of negative x, that's just equal to the cosine of x.
Okay.
Okay, so the cosine of negative pi is the same thing as the cosine of pi.
Yeah.
All right. Okay. So I would keep those in mind as well.
Okay.
Now, when you look at the unit circle,
Mm-hmm.
Don't forget that tan is undefined, right? At pi over 2 and 3 pi over 2.
Yeah.
So that you want to, choice B says something about being undefined, then
That's only for tan, because tan eventually pops up. It asks me about cosine, and then it asks me about tan.
okay, all right.
And yeah, it says undefined.
Okay, perfect, hon.
Alright. Yeah,
What
there's a lot of like these problems in here. The next one is like sine of negative 3 pi over 2, so that's technically sine of pi over 2, so that'd be 1, correct?
Right, it's a sine of negative 3 pi over 2 is the same as you negate. You put the negative on the
Negative
outside.
sine. Yeah, negative sine of 3 pi over 2, which is the sine of pi over 2.
Correct.
Alright. And cosine would be 0. Tan's undefined. Alright. Find the exact value of the following expression. Sine of 7 pi over 4. Isn't that, I can just go in the unit circle for that?
Sine of 7 pi over 4? Yeah, just go in the unit circle.
5, 6, 7.
Sorry, I gotta write things down, honey. I'm not auditory, I'm visual, so I'm just writing randomly on the paper.
Okay, that's fine.
I'm gonna go